Hi guys, my name is John, this is Michael.
Hi guys.
Actually we are quite happy to see so many people here, even though Jen is talking next door. It's an honor to see you. We'll be talking about Cisco NAC and how to hack it. Basically, let me just run you through the agenda real quickly. I'll do the introduction with some marketing buzz on Cisco NAC, which is quite short. Then I'll delve into some NAC technology details and into a short analysis of Cisco NAC. And after that, I will hand over to Michael, who will be basically telling you how we approached hacking Cisco NAC, what we did, which tools we used, and so on. And then at the very end, we'll show you our live demo of how we hack a Cisco NAC secured network. That'll be the end then. I see there are still people trickling in, so let's just give them about 10 seconds to sit down before we continue. Okay. So I'll start with the part one with the introduction. So why is Cisco actually selling Cisco NAC, right? That's the question. They're selling it because basically customers are willing to pay for it. I guess that's one of the most important reasons. Then you could ask, why are customers actually willing to pay for it? Well, Cisco makes some pretty cool promises about Cisco NAC. I'll show you on the next slide. That's a screenshot from the website, right? And if you go there, and the very first sentence, it tells you NAC business benefits dramatically improve security, right? And extends existing investment and so on. So they make a pretty cool promises. And that's why basically they're selling it and people are buying it. We'll talk about the promises a bit later. Okay. The idea behind Cisco NAC, for those of you who don't know, it's basically grant access to the network to a client based on the grade of compliance to the defined security policy. We define a security policy, we measure the level of compliance to the security policy, and based on that we grant access or we don't, or put it in a quarantine section or a mediation section. It's quite important to notice that this is basically a compliance solution. And if you talk to Cisco engineers, they'll also tell you so. If you talk to Cisco marketing, they'll tell you it's a security solution. And I don't know who of you attended Dan Kaminsky's talk this morning. Who was in Dan Kaminsky's talk? Remember what he said? If you're using a product which was not designed to be a security product, don't be surprised if it doesn't measure up for security, right? So same basically applies here too. The security policy can usually be broken down to things like patch level on the operating system, antivirus signatures, the absence of unwanted programs, and if the desktop firewall is up and running and stuff like that. And we want to measure compliance against that security policy. So basically, where is the policy actually measured on any kind of access device, regardless if it's wireless, a switch, a router, some VPN connection. There is a device in Cisco NAC which basically detects a new system coming up on the network, then queries the device for some credentials, some information, relays that information to a backend server, where then these credentials are compared to security policy. The backend server derives a so-called token, which is then associated with restrictions. These restrictions are communicated back to the network access device, and then they're enforced. That's basically how it works. We'll look at this in a bit more detail. So what is Cisco NAC actually, if you're looking at a technical level? Anyone understand? What is it? Chinese, Korean? I don't. I found this picture on the Chinese Cisco website, and I really liked it because that's how we felt when we started with Cisco NAC. Right? How does it work? Okay. There is a very famous picture. You'll find it in just about any Cisco NAC slide and any Cisco NAC presentation, and it looks a bit like this. I didn't just steal it; I really redrew it with Visio because I didn't want to get into anything like stealing property of Cisco. Basically what happens, we have on the client, on the very far side, on the left client, there is a endpoint security software running, which is called a CTA. It's a Cisco Trust Agent. The Cisco Trust Agent is basically what will be in the focus of our talk today. And it relays information to the access device. Depending on the kind of access device, it relays this either over layer 2, if it's talking to a switch, or over layer 3, then using UDP as means of transport. And basically, it's all wrapped up in EAP. The access device then transmits it back via radios to a backend server, which is in Cisco solutions always a Cisco Secure Access Server, the ACS, where these credentials are then checked. And we'll look at that in detail now. There are 3 different flavors of Cisco NAC. The first one, and that's the one we'll be showing also in our demo, is a NAC Layer 3 IP. That's what it's officially called. Access restrictions are implemented as IP access lids on a physical interface of a router, for example. The access device is a Layer 3 device, like a router, a VPN device, or a firewall. And the communication between the client, the CTA, and the network access device takes place using PEEP over EAP over UDP. That's just for encapsulation. NAC Layer 2 IP is a bit different. Access restrictions are again enforced as IP access lists, but not on a physical interface of a Layer 3 device, but on a VLAN interface of a switch. That's why it's called Layer 2 IP. Communication path is basically the same, PEEP over EAP over UDP. And then there's the third one, which if you ask me is actually from a security point of view my favorite one, which is NAC Layer 2 802.1x. As the name says, it uses .1x port control to restrict access to the network. It's obviously .1x you usually do on switches, not on VPN devices or routers. And this is basically the only NAC flavor where there's any means of authentication of the client, and where you have the option of restricting communication in the local subnet of the client. In all the other ones, you have an IP access list. IP access list basically only restricts you from leaving your local network. It will never catch inside the network, right? And that's something different here. Okay. Of course, there's some sort of different features of what's supported and which device. I will sort of go over this a bit faster so we can have more time for the show. You can all read it up. We have also a very long paper on this. And this is just a comparison of the features. Quite interesting is the Cisco Trust Agent. That's a piece of software you need to install on your notebook or on your PC to get this thing running. And it basically has 2 tasks. Its first and main task is collect data, which is so-called posture data or credentials about the client, and forward it. That's basically the main issue, or the main task of this, right? Collect, number 1, forward it to the access device, or the ACS via the access device, number 2. And quite interesting, it has a plugin interface for third-party vendors, NAC-enabled applications. Like if you have a McAfee antivirus solution, you can plug it into the Cisco NAC solution via the plugin interface, if McAfee supports it. McAfee does, in this case. And there's a second interface, which is a scripting interface. This scripting interface basically enables you, as the administrator of a NAC network, to write simple assessment scripts yourself and relay the posture data of these self-written tests, like is there registry key XYZ, what's the value of the key, and relay that back and test against that too, right? So we have a plugin interface and we have a scripting interface. Okay, and you can see that also in the architecture. You can see at the very top layer, there's the vendor plugins from third-party vendor. Cisco provides some plugins itself. We'll have a look at the Cisco plugins later on because they're quite interesting. And custom apps is basically the scripting interface. And you see that there's basically 2 means of communication with the Trust Agent, which is first of all via the API for the plugins, Cisco plugins and vendor plugins. This interface is basically not disclosed by Cisco. It's only given if you can buy a license to use it, the API. And then the custom apps plug into the scripting interface, which is well-defined, and you can access that. And then at the bottom layer, you can see there are 2 means of communication with the network. It's one EAP over UDP, and the second one is EAP over .1x for the NAC Layer 2.1x. Okay, so now let's talk about what information is actually relayed and how does it look like. This is the so-called posture information. They are actually collected in attribute value pairs, in AB pairs. And the attribute part is quite big. There's, first of all, there's a vendor ID. The very first part is a vendor ID, and the vendor ID goes by the IANA SMI assignment, so it's basically the same as in SNMP, if you know SNMP, right? The OID of the SNMP trees. Then there's the second part is the application type. So there are well-defined values for applications. We'll have a look at that next slide. Credential name, and then of what format the collected information is. Is it a string? Is it an integer? Is it a date format, etc. pp. Okay, and for all plugins and scripts you want to use, you need to describe the information collected, the posture information collected, in an inf file. And Cisco provides a couple of these too. So just to give you a short, okay, we can see the very left of the slide, I guess. So basically there is an ID1, application ID1 is the so-called Cisco posture agent, which is shorthand name is PA, collects information about the agent itself. Application ID2 is Cisco host, which collects information about the host, like running, operating system, service packs, hotfixes, and stuff like that. And you see application ID4 is firewall, application ID3 is antivirus, so McAfee would have an application ID of 3 for antivirus, for example, okay? And if we look at two plugins which are provided by Cisco when you just install the system, these are the so-called posture agent plugins and the host plugin, and this is basically the sort of information you can collect and relay. Information about the agent in the posture agent and the OS type and OS version and service packs and host and hotfixes and FQDN and so on through the host plugin. This will be used in our showtime, in our lab, in our demo for hacking it. Okay, we'll be hacking Cisco NAC with sort of these credential types. That's why we're talking about them here. Now, what happens if you then relay the information to the backend server? And for each application, the server basically derives a so-called application posture token, basically a label saying, okay, according to my policy, this is healthy, or according to my policy, this should go into checkup. Right? This is a so-called application posture token. And now you have a multitude of applications like antivirus and host and firewall, and you get a multitude of application posture tokens. And from all these application posture tokens, a system posture token is derived, which is basically the application posture token which will give the least access on the network. Like if you have quarantine, checkup, and healthy, effective will be quarantine, least privilege basically, principle behind this. And this posture token then is associated with restrictions, and these restrictions are then enforced on the network access device. Okay, that's how it goes. These posture tokens, application posture tokens and system posture tokens, they are well-defined. They have a well-defined meaning by Cisco, and they go from healthy to unknown through checkup, transition, quarantine, infected. I will not go through this. You can have a look at it if you want in the slides. They're up on the BlackHat side. And I told you that all the plugins are described in infile, and here's just a sample of the Trend Micro antivirus infile, and you can see everything's in plain text in there. It tells you plugin name, Trend Micro antivirus, posture plugin DLL, and it tells you application type 3, which was antivirus, and then it gives you a list of attributes it relays. Attribute number 1 is an unsigned 32 and attribute number 2, again, unsigned 32. Application posture token, system posture token, they are all